In today's class, I'm going to show you how to interpret the results from a very simple experiment. But before we do that, let's briefly review the previous lesson where we introduced some new terminology.
We learned what the word outcome means when talking about experiments. The word response is also used instead of outcome. We learnt about factors, which we sometimes called variables. Factors or variables can either be categorical or numeric, and we discussed examples of both types.
It might seem strange that I'm showing you how to analyze the results of the experiment before I even show how I designed the experiment. Sometimes, though, it's useful to see the end and then work backwards to the beginning. The experiment I'm going to describe here has one outcome: the profit made in one day when selling a specific type of product in a store. Remember that profit equals income minus expenses. So when the store owner calculates the total income and then subtracts the total expenses, that number is called the profit and is the outcome of our experiment. The objective of this experiment is to increase profit. We defined what an objective was in the previous class. Now this experiment has two factors. The first factor is the amount of light in our store. We can use a dimmer knob to control how much light is in the store. We can put that knob at 50% or 75%, for example. A low amount of light or a high amount of light. It is always good practice to predict what the effect of the factor will be on your outcome. In this example, do we expect more lighting to increase the profit? Do we expect more lighting to perhaps decrease the profit? Or do we expect more lighting to really have no effect on the profit? We'll look at the results in a minute.
The second factor we're going to consider in the experiment is the price of the product. We could sell the product for $7.79, or we could sell the product for $8.49. This again is a numeric variable.
Try to predict what the effect of price is going to be on the outcome. Do we expect a higher price to increase the profit? Do we expect a higher price to maybe decrease the profit? Or is it possible that a higher price has no effect on the profit? Pause the video for a moment and write down what you predict the outcome will be for changing those two factors. Now let's take a look at the results. We have to consider all combinations in our experiment. The easiest way to consider this is with a simple visualization. Let's start with a horizontal axis for the dimmer amount, where we have a low amount of light on the left and the high amount of light here on the right. Then add a vertical axis for the next variable, price. We have a low price here at the bottom and then a high price at the top. So there are 3 experiments here so far. There is actually a fourth experiment we should also run. It is the combination of high amount of light with high prices. Let's assume you have 4 days and you could run these 4 experiments, 1 per day. On the first Monday, you run the experiment with high amount of light and low price. And let's say you get a profit of $570. Then the next Monday, you run the combination of low amount of light and high price, and the profit is $370. The following Monday, you have prices that are high and with high amount of light, and the profit there might be $450. Then the last Monday, you have the final experiment with low light and low prices, and your outcome is a profit of $490.
Here are the results in table form. We are going to see this format regularly in the course. I'm going to explain in a future module why we ran the experiments in a different order to that shown here in the table. This table order is called standard order.
The simplest way to analyze this data is to use a visual analysis. and no statistics are required to do this. Start by drawing a square of the 4 experiments. As before, we have the lighting factor on the horizontal axis and pricing factor on the vertical axis. Next, add a minus sign and a plus sign onto the axes to help indicate the low level and high level. We sometimes also write what the value of the low level and the high levels are. Transfer the values of the outcome variable from the table onto the square. In other words, copy those profit values, the outcome variable, across. We call this a cube plot. Later on, when we have 3 factors, you will see it really is a cube. So 490 is written at the bottom left because that was the outcome profit when we used low lighting and had lower prices. We add the 570 at the lower right, 370 at the top left, and finally 450 at the top right. Now we are ready to analyze the results. First, let's analyze the effect of lighting amount. We have 2 chances to judge the effect of lighting. The first is to consider the difference between the high level of lighting compared to the low level of lighting, but keeping prices at their low values. When we do this, we see the difference is 570 minus 490. That's a difference of $80. Now let's look at the difference in lighting when pricing is at the high value. This time it's 450 minus 370. That's a difference of $80 again. So we can see then the effect of lighting causes our profit to increase by $80 as we move from a low level of light to a high level of light. This effect is consistent both at low prices and at high prices. Now let's consider the effect of adjusting prices. At low amounts of light, we can compare $370 in profit to $490 in profit. We interpret this as follows. As prices are increased, the profit will in fact decrease by $120. We can also consider the effect of adjusting prices at high levels of lighting. This time we have 450 minus 570. That's a decrease of $120 again. So let's recap. The effect of lighting is that it increases our outcome variable. Our profit goes up by $80 when we move from 50% on the dimmer to 75% on the dimmer. So it's a good thing to use more light in our store. Pricing, though, has an interesting effect. It shows that our profit decreases by $120 when we raise our price from the lower price to the higher price. This example was in fact quite simple. Most experiments will not have the same 2 values on the left and the right hand side, or on the top side and the bottom side of the square. Before we end the class, I want you to consider what could have gone wrong. What if, on the day that we did our experiments, there was bad weather and we had fewer customers come to our store? What if we repeated the experiment a second time? Would we get the same profit outcome value? In other words, is our experiment reproducible? Those are important points we have to bear in mind, and we're going to consider them in the coming classes. See you next time.